Okay, so this is going to be a review of entity relationship modeling and what you need for the final exam. So I'm going to cut to the chase and give you a synopsis of this. It's about 58 slides, but let me just review this for you because on the assumption I've already done this once, so let's do it again. What we're going to do is kind of look at the stages in terms of developing the entity relationship diagram. You can read through all this other stuff in the beginning, but let's just go over the concept of the model. We only have three things in this model. We have entities, relationships, and attributes. And the purpose of the model is to get you to identify the entities, those relationships, and those attributes. So you're going to be given a problem description on the final exam, and you'll be taking the project description, and you'll be identifying these components and drawing them out on a piece of paper using any symbol set that you want. You don't have to use any particular symbol set. So a lot of people like the arrows, a lot of people like the crow's feet, the single dashes, the multiple dashes for multiple versus single. It's completely up to you in terms of what you want to do. The most important thing is to make sure you identify the entities and the relationships. Entities are nouns, person, place, or thing. They can also be concepts. Entities don't have to be real existence. So if I said students take classes, students and classes are entities. And the relationship is that they take them. So you'd have student, classes, takes in the middle. You draw a line between the two of them. If you put the little diamond symbol in there, you could put the word takes inside of the diamond symbol. If not, you could just draw it on the line. You don't need a diamond symbol. Why do you need a diamond symbol? It's because you can have up to four participating entities in that one relationship. So the symbol of that diamond, it's got four sides to it. Makes it easier to draw the connection. You don't really need it unless you got 4 or 3 or more than 2. When they call it 2, it's a binary. It's between one relationship with one entity with another entity. You could have 3 entities in there. You could have 4 entities in there. So it depends on how you want to draw it. You can put, a lot of people like to put the diamond symbol in there anyway, even though there's just 2. Because who knows, maybe the next sentence is going to say something about students take classes with professors. And then if that's the case, we have 3 participating entities, and we're going to have 3, we're going to put the diamond in there. We could say that students take classes with professors on campus. Or a student takes classes with professors online, when we'd have a location. So we'd have 4 participating entities in that relationship. We'd have students who take classes. So we have students on the left, classes on the right, takes in the middle. Put a little diamond symbol in there. Up on the top, I'd put the professor up there. Up on the bottom, I'd put the location, online or on ground. If you got that, you'll ace the final. That's what you're going to need to do on the final. You have to figure out, are these guys all participating together? Are they not participating together? If they are, then here's the diagram. Here's what it looks like. It's not that hard, actually. It's pretty straightforward. Okay. So what I just described was the big picture. Let me give you some more details on this. The entity has entity occurrences. Most people mess up here. They'll go, teachers, students take classes in biology, and students take classes in computer science, and students take classes in business administration, and students take classes in human resource management. Aren't they all classes? But I gave you 5 different instances. 5 different entity occurrences of the same concept of a class. A class is a class. So instead, on the class entity, you'd put a little attribute on there that said description, or type, department. Maybe you'd actually have a lot of those things in there. Those would be attributes that are deciding what kind of class this thing is and how we're going to describe it and how we're going to keep track of these classes. So that's what's meant by an attribute. An attribute helps identify each one of the individual entity occurrences. The entity is the class. The occurrences is a biology class versus a software engineering class versus a computer science class. Those are different occurrences of the same entity type. Don't get confused and write biology class, chemistry class. There's not 5 different entities. It's one entity. And we have an attribute that decides what they are. And the attributes make the entity occurrences known. So we have class type, class description, class code, teacher in the class. And that's how we're connecting the teachers with the classes with the students and everything. Know that entity types can be non-existent. So a class, well actually a class technically is sort of a hybrid. You guys are sitting here, I think you're probably in existence. Even the online class, you'll be logging into something, you'll still be in existence. But what about a sales receipt or an invoice? It's a piece of paper, but it's a concept of a receipt. You know when you go and you buy something at the store, they give you a receipt? Most people throw it away, or some people save them, especially if you're going to want to return the item. But long story short, it's not a physical thing, it's a conceptual thing. It's a record of your transaction. It says, hey, I bought this thing. It's evidence, it's proof. It's still an entity, is what the point's trying to make. And work experience is still an entity. And a grade in a class is an attribute for a class. The class is an entity. Viewing, inspection, those are all like entities. So here's how you draw the diagram. As I mentioned before, let's just go down here. This is the two participating entities. A staff, branch, and it says branch has staff. We have a little arrow in here. This is one way of doing it. You don't have to put the arrows in. You don't like arrows, don't put arrows in. It just means that you're supposed to read it from this left to right instead of right to left. No, right to left. You're reading it right to left instead of left to right. So my right hand, my left hand. The relationship name has is above the line. You could put it in a diamond symbol if you want. I'm not going to be testing you on your syntax. I want to see, did you identify staff, did you identify branch, or did you put branch and staff in the middle? Or do you not have anything there at all and we just have this line? Well, actually, that works in this case. It's assumption that there's some relationship going on there. If you want to be more descriptive, I'm not going to take off any points if you don't put any relationship names on there. If you draw a line between these two and you make these look like they're rectangles, then it's going to be pretty clear what you're talking about, hopefully. So that's really referring to the degree. The degree of relationship is the number of participating entities in the relationship. This is 2. So we have a 4-degree one. We have 4 participating entities. It's really, we can have more than 4, but it gets kind of hard to draw it. Usually 4 is the max that we're going to represent in an entity relationship diagram. We can also have the relationship cardinality and the relationship participation, which I'm going to review in a few minutes here as well. But in terms of the relationship of the degree, 2 is binary, 3 is ternary. You don't really need to know that. It's just know that you can have more than 1, and you can have up to 4. Well, you're going to have more than 1. Unless you have a recursive relationship where you have a relationship with yourself. If you're a staff person who manages a branch, well, you have a branch in there, you have 2. But the staff person could be a branch manager. That's a recursive relationship with yourself. So here's a binary relationship here with a property owner who owns property for rent. It's a property owner. And then we made up this word here. You don't have to use real words when you describe the relationship. It's helpful for readability to be able to describe the relationship in real words, but not necessarily a requirement. I could just say works for, or 2 words, 1 word. You don't want to put a whole sentence down here. But you can put, like, you know, this made-up word, P-owns. It means property owners who own properties for rent. So here's our 3 participating relationship. 3 entities that are participating in a relationship together. A staff who registers branch at a client. And remember, you can read this in any direction that you want. So you can say branch is where staff register clients. Or clients go to a branch to register with staff. So, and here staff registers a client at a branch. I'm thinking that we read left to right. This relationship holds true. It should also hold true in the opposite directions as well, the other directions. And here's our 4. This is about as much as we're going to put into a diagram. So a solicitor who arranges a bid on behalf of a buyer that's supported by a financial institution. Or that could be students who register for classes with teachers on campus or off campus or at a location. So what if IT had multiple campuses? Then we would have multiple locations for multiple classes. So, which we don't, we just have 1. But anyway, long story short, it's 4 different entities participating in the same relationship. And then we have entity types, relationships. We also have attributes that we could put on the relationship. So normally we think of the entities as having attributes, and the attributes associated with the entities are going to be describing components that belong to the entity. We could also have in ranges, well, there might be a time or a date or a location in this particular example where we're going to arrange it. Well, the location is already a financial institution, so maybe the time or date, you know, a 9 o'clock appointment, 10 o'clock appointment. That would be a relationship attribute, an attribute that belongs to the relationship. So recursive relationship, to refresh your memory on this one, is a relationship type where the same entity is involved with the same relationship. So it's more than one's in a different role. And we have different roles that exist with this. So relationships might be given role names to indicate the purpose of the participating entity, type, and what role they play in that relationship. And here's an example. So if you're hit with an entity that has a relationship with itself, and it's a recursive relationship, it's like ding, 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 recursive relationship. Oh, look at that. The employee is the supervisor. Okay, then you just put two different names on there, employee and supervisor, or supervisee and supervisor. And it's really the same relationship. You're putting two role titles on it, so you can tell the difference between the two roles and the two people that are participating, but it really is the same entity. So you draw a square like that, maybe you can, actually I like to put a little circle thing, a circular. But this looks like because this looks like a square on top of a square. I don't like that look. I usually will just like put like a little round thing next to it and then put supervisor and supervisee on it. If you put the two roles and you put like a little round circle around it, or you put like a little arrow going to itself, it's pretty obvious what you're talking about as recursive relationship. I've had some students write down here, recursive relationship. Oh, that's good as well, but you don't have to label the diagram if you're clear about what you're doing. If you're not clear about what you're doing, or you think there's some doubt, put a little label down there if you want. It says, hey, this is a recursive relationship. Look at it, I found it. It's a recursive relationship. I can't remember right now if I even gave you a recursive relationship, but if I did, then this is how you'd want to put it together. I don't think I did actually, but I'm pretty sure I didn't actually, but we'll see. I can't remember. I actually made it as straightforward as I possibly could. And in fact, you're making a diagram out of tables that are already created. So, in fact, I didn't even give you a description because that was harder. So. And then the diagram that you're translating doesn't have a recursive relationship in it either. So I could have made this a lot harder, I think. But anyway. And actually, this is a little bit of trivia, though. Those roles really got translated into object orientation because those are object roles or associations. See, the funny thing is about entity relationship diagrams is that it was never meant to show recursion, and it was never meant to show roles or associations. It only shows relationships. So this actually was kind of a new thing added when object orientation came around, and they said, wait a minute, we're going to take this concept, we're going to turn these entities into objects. Now they play different roles. So this object could have a relationship with itself. And all of a sudden it's like, oh, recursion? We have that? And then that sort of got added to the diagramming technique like years later after people started using it. So it's kind of funny, there's no really right or wrong way of creating the recursive relationship symbols because it's kind of an afterthought to begin with. So entities associations with two distinct roles as well. So this is the interesting thing is then entity relationship diagrammers started doing this. Well, a branch, staff manages a branch and a branch has staff. Don't we have two separate roles? Well, aren't those two separate relationships? It's like, yeah, but isn't it really an association? So object orientation took this and made it better, actually, made it clearer. So in entity relationship diagramming, we have two roles, and the roles turn into two separate relationships, which is how we can come up with that recursive relationship. In object orientation, you'll never see that. Instead, you see one single line drawn between the two objects, and you see the association and the relationship both represented with the two different roles. Entity relationship, we just split it out into two. So you don't have to work with object-oriented concepts. There's no such thing as object-oriented databases on the exam. There's no reference at all to anything object-oriented. You just have to worry about entity relationship. And if you're worrying about entity relationship and you think that there might be two roles, then draw two lines Draw 2 lines, put two labels on it, and it's 2 separate relationships. Because that's all we can do in entity relationship diagramming is we don't show associations. So we just have multiple relationships. Yeah, I'm a teacher, and I'm also a student, and I'm also, all these other things that you might be, that are associated with your different relationships with different entities. So here's a manager that manages a branch office. We have a manager and we have a branch office. We have a manager's relationship. Then we also have this branch office that has a staff. Well, the relationship is still with staff and it's still with branch, but one of them is a manager and the other one's staff people. So it's half a dozen or another. I probably would have just written one line and put both roles on the line, which is more the object-oriented way of doing it. You're not going to lose points if you have multiple lines versus one line, or 3 lines instead of 2 lines, or 5 lines instead of 1 line. I really don't care. I'm looking to see, did you identify the relationship or ships? Did you get one or more than one? That's okay. Did you identify the entities? If you took a relationship and you turned it into an entity, that's a problem. If you just said, oh, there's 15 million relationships because you're really right into the question, which there's not going to be more than one relationship. So if you had multiple relationships going on, okay, you're really thinking a lot into this. Okay, good. As long as you don't turn them into entities, you're in good shape. So my advice is just don't think out of the box. Just think inside of the box. Put blinders on and just go with the obvious scenario and don't read into it. If you read into it, great. You're just going to make your life more complicated. And just make sure if you're going to read into all those different relationship types, to put them as relationships. Don't put them as something else. Don't make imaginary entities out of that. So it's kind of like, you can think about it. You can say, well, what is the relationship between students and classes? Well, they take classes. Okay, sometimes they pass classes, sometimes they fail classes, sometimes they attend the class, sometimes they don't attend the class. You can come up with all these different relationships students have with the class. They do homework for the class, all the different things, and then you can list them all out, like dozens, or you can just say students take classes. Anyway, what I'm looking for is, did you know that students take classes? I don't care if you have 15 other relationships in there going back and forth. They attend the class. They get a grade in the class. They fail the class. They pass the class. They do homework for the class. They take the class more than once. I don't care. Attributes. Attributes are describing the entity. The attributes belong with both the relationships and also the entities. Normally you see more of them with with entities, not as many with the relationship. But you can put an attribute on a relationship if you'd like. And if you're working with a set of tables that's given for you, you should know that those tables are both a combination of entities and relationships. Because when we translate, if we were to work forward, we would start out with a textual description. We'd make a set of tables out of that. From the tables that we would create an entity relationship diagram out of that. We read the diagram to create the tables. Some of the items in the diagrams are entities, some of them are relationships. Attributes don't turn into tables, they become part of tables. So first thing we do when we translate those diagrams is make a table out of every one of the entities. Then we take the relationships that are multiples. If there's any multiple component of that relationship, it turns into a table. If there isn't, it's a one-to-one. No table gets created out of that. Instead, the one side becomes part of the other table. We combine the data from the attributes from the two tables and we put the attributes together to form the connection. If we have a multiple, then it makes sense to create a new table, because then otherwise how many multiples are we going to stick in that table? Can't. That's when we come up with the bad design of the color 1, color 2, color 3, color 4, and we arbitrarily decide we can have up to 5 colors. Instead, you put another table that says colors, and then there's a link, color number, that goes into that table. It tells you which color we're talking about. Or we have, a linkage that shows the relationship between this table and this table over here, and all the lists of color combinations that could exist are in that table. So, what I'm going to do is I'm going to give you a set of tables. I'm going to say take the tables and turn it into the diagram. Know that some of those tables are relationships, and some of those tables are entities. And because most people would look at the table list and they go, oh, all these are just all entities. They draw a bunch of entities and they connect the entities together. That's the wrong way of doing it, because you have to look at the relationships between them. So if I have students who take classes and I have a student table, a classes table, and I have a registration table, that registration is not an entity, it's a relationship. And people will fall for it because they'll look at that and they'll go, oh, entity called student, classes, an entity called registration, and then draw lines between all of them. That's a for those people who are sitting here listening to me, that's going to happen to you if you're not paying attention. Because what's going to happen is then you're going to lose 2 points. I'm going to give you 2 points. I'm going to -2, -3 off the bat. Because you can't take a list of tables and translate them all into entities. Because we have 3 components in entity relationship diagram. We have entities, relationships, and attributes. Well, the attributes are no-brainer. They're already given to you. They're inside of those tables. But some of those tables are relationships, and some of those tables are entities. So the people who will just look at that, it doesn't really matter because you don't have to pass it anyway, but if you want to get easy points on this, just draw a real diagram out of it, and don't fall for the one entity that's connected to another entity. Make them all into entities, you're on the wrong path. Because there's got to be a relationship in there, right? Yeah?
So when we design table from ER diagram,
Oh, then you go, yeah?
So like the example you have given, student, classes, and registration, registration is a relation.
Uh-huh.
So student classes, we have 2 tables. What about the relation?
If students take more than one class, it would be a separate relation. The relation would be called registers. So if I gave you a scenario and I said students take classes and they can take as many classes as they want. Student, classes, and then the relationship is registers. And then it's a one student may take many classes. So it's a one-to-many. So if I were to take that textual description, I'd have that binary relationship going on with 2 entities. That's the diagram that I would create. If I gave you the diagram and I said, give me a list of tables, I have 3 tables. I have 1 student, 1 classes, and then 1 relationships table. And the relationship table gives me a list of students and which classes they've signed up for, and that turns into a registration table.
And the relationship table will have 1 and N1. Like student.
The relationship table is going to have a key from students and a key from classes.
Okay.
Because we have to key both of them together to show the multiple relationships that exist between students and classes. But what I'm going to do is I'm going to give you a student table, a classes table, and a registrations table, and I'm going to say draw an entity relationship diagram. And the stupid people are going to go, I shouldn't say stupid. The classic mistake you're going to fall into is you're going to draw a rectangle and you're going to put students, and you're going to draw a rectangle and supposed to put classes, and you're going to draw another rectangle and you're going to put registers, and you're going to draw a line between the 3 of them, and you're going to get -2 or 3 or whatever. I can't remember how many points that's worth. Because you don't have 3 entities. You have 2 entities in 1 relationship. Your question.
But you don't need to have a relationship table as such, right? Because a student.
If a student was only allowed to take 1 class and 1 class only, 1 student took 1 class, and you had a 1-to-1 relationship, there's no table. Instead, you have a table called students and class. You have a field inside, an attribute inside of the student table that says, which class did you register for?
For example, a customer order, so the order table can have the customer ID in it.
Correct.
Not necessarily you need to make a relation table.
You don't need a relation table if it's a 1-to-1.
It's 1 to.
If it's a
The customer can
1-to-many,
have
you
many
need a
orders.
relationship table.
No, because the customer can have many orders. And your order table has the customer.
Then you have an
ID.
order table. If a
So if the
customer if a customer is purchasing items they have an order in between of them. So customer purchases items. It's the same way as students take classes. It's the same scenario. The purchasing is a purchase order or an order that's writing, and you have three tables that come out of that. The customer table, the purchasing table, or the orders table, and the items table. And inside the orders table, you have customer number 1 ordered this item, customer number 1 ordered that item, customer number 2 ordered, you know. They have all the different matches between all the different customers and all the different items, and you have for each customer, you have different orders that are put in there. It's the relationship of the customer ordering items.
So we have two tables. One is the customer, the product.
You have three tables.
And the relation table, which is
Yeah.
the order.
Correct. You have three tables that come out of that. You have the customer table, you have the items, and you have the orders. It's the same thing. Customer goes to Fry's and buys something. You have three tables. You have the customer table, you have the items that are listed in Fry's, the inventory, and then you have the sales receipt table, or purchase order table, or however you want to call it, transaction table. The transaction table is going to show that customer Hacker goes to Fry's, buys this item, and this item, all in my sales receipt. That's in my transaction table.
But your ER diagram will just show only two entities
Here.
in relation.
Correct. Your ER diagram only has two entities with one relationship.
That we have seen one ER diagram 6 or 7 slides before, and
Yeah.
that will be the right ER diagram to show the scenario we're discussing more of.
This one?
No, it says has staff relationship. Yeah, this one. So we will be having a class student and a relationship.
If this, yes, correct. If this relationship, if we have a lot of staff that are at a branch, we have three tables. We have the staff table, we have the branch table, and then we have the table that keeps track of which staff are at which branches. Just like we have a customer table, we have an inventory table, and we have what did they buy? Or a student table and a classes table, what did they enroll in? What did they all register for? So the scenario, if it's a multiple on any one of the ends, if it's a multiple to multiple, that's a no-brainer. If it's a one to multiple, a many to many is a new table. A one to many is a new table. A one to one is not a new table. So you can go and you can kind of think about it and say, well, if it's a one to one, it's the only scenario where you're not going to get another table out of that. If it's a one to one, I say, okay, I only have one staff. Each student can only take one class. We don't need an entire registrations table. We only need to keep track of which class the student's in. So we have one that says class. So we move an attribute from here, if this was class, to the student table to say, what class are you in? If it's classes, we have a problem storing multiple values in a single table. So we can't do that. Instead, we have a registration table that keeps track of this student's taking this class, this student's taking that class over there, this student's taking that class over there again. So we have multiples. Then we have to we have a table that shows that. Yeah.
So the example I was talking about, the customer, the items, and the orders. Basically.
If the customer is allowed to order multiple items, we have a orders table that keeps track of which customers purchase which items.
Right. So that's the relation table.
Uh-huh.
And when you draw the ER, so you have the customer, you have the item, and the order is your relation.
Uh-huh.
And when you draw the cardinality or the optionality, so does it
One customer to many items.
many items?
So it's a multiple. If it's a multiple, that relationship turns into a table. Otherwise, how are we going to keep track of the multiples? Whenever you have more than one, you got to keep track of the more than one. Otherwise, you end up with a second normal form. If you want a third normal form table, you're keeping track of the relationship table. If you don't have a relationship table, then you have customer order, item 1, item 2, item 3. That's a second normal form table. Item 4, item 5, item 6, item 7. And then you're going to arbitrarily say they can only order 10 items. Or 5 items or 4 items. It's like students who could only take 2 classes because the table only holds 2 classes.
So when we draw a relationship table, it becomes a 3 automatically.
You don't put the number on it unless you're going to enforce the business rule. So if you have a 1 to 5, You can make a second normal form table by taking and not creating that third table. You can actually just create 2 tables and go class 1, class 2, class 3, class 4, class 5, because the business rules say you can only have 5. So you can actually turn that into a second normal form if you wanted to. If you really wanted to make it a third normal form, you'd have a separate table. But that's kind of the decision that you'd have to make knowing the business rules. Anyway, the point I was trying to make was just keeping in mind that sometimes those relationships, they turn into tables. And the trick to it is that it's going to be a multiple relationship. A single valued relationship, not going to be a single, only one student only takes one class. There's absolutely no need to turn that into a table. Instead, you just bring the attribute over from the one side, put it into the other one side. So you have it combined into one, which is how our attributes are playing a part in here. We also have, we also have more than one relationship. If we have more than one relationship, one of them might be a single, the other one might be a multiple. As an example, international students take classes, domestic students take classes. Well, that's a single. You're either international or you're domestic. Hopefully you're not both. So, well, maybe you are both, I don't know. But long story short, you're going to have a column that says international, or an attribute that says status. And the status of your student is going to be either international or it's going to be domestic. Those are single entity existences, single occurrences. You don't have multiples with that, so you don't have an extra table that says, because you could, if you had the ability of the student to play multiple, so the student is international and they're also domestic, then we'd have a relationship table called status. It would say student A, domestic, student A, international. We'd be able to show both of them. And then we would have status for student A in the student table that would be a status, number 1. And number 1 is both international and domestic in the status table. Most people wouldn't do that. They'd fix it, different categories, and make it into a single. So a student is either A, B, or both, C, which is a combination of A and B. And then they put A, B, or C, and they have it predefined. Well, you're not going to get anything like that on the exam, but that's just one of the kind of scenarios people run into, and they kind of figure out, oh, do we need a separate table for that? It's kind of like students can only take 2 classes. Well, if you can only take 2 classes, why not just have class 1 and class 2? Why do we have to worry about class 3? It doesn't exist. So, alright, so attributes. We have simple attributes and we have composite attributes. A simple attribute is a single component. A composite is multiple components. Address is a classic multiple component attribute. And address is what? A city, a state, a zip, a street address. All those things together make up the address. So wouldn't a dependent on a health insurance policy who belongs to an employee, well, the dependent is going to be multiple because we're going to have the employee ID, the dependent ID, or dependent name or something that's going to associate with that. Could be a composite attribute. So with weak dependents, we can turn those weak dependents into weak dependents by creating composites for them. And the composite is a combination of the employee and the dependent information that makes them composites. We also have composites with addresses and with multiple pieces. Like, for example, a telephone number is what? An area code, a prefix, a suffix. That's a composite as well if you want it to be. Or you can make it into a simple attribute. Make it a text that says telephone number. Or make it a text that says employee. Or make it a text that says dependent. So in terms of attributes, we have single valued attributes and then we have multiple valued attributes. So single value holds 1 value. So an attribute, well, like classes as an example. It's an entity. If we turned it into an attribute, it would be a multiple valued attributes. And if we did that, what we're going to end up with is then having to hold multiple values in a single value, which is you don't want to do. You don't want to hold multiple values in a single valued attribute field. which is the scenario where you go color 1, color 2, color 3, color 4, color 5, because you really have a multiple number of colors, but you're putting it into one field, so you have to make 5 fields to show 5 different colors, or 5 fields to show 5 different classes if you have multiple attributes. So single versus multiple valued attributes, same problem with single versus multiple value entity occurrences. We also have derived attributes. Derived attributes are, which are example, age, which is what the birth date minus the current date. Or we have number of students. Or student ID can actually be a derived attribute. It can be like a counter, you know, an incremented counter value. So, keys. Most people at this level have the keys down. If you've taken any sort of database class in the past from an undergraduate course level, you know about keys, primary keys, foreign keys. The candidates, remember that candidates are anything. We care about candidates because of normalization. So we might have identified a primary key. We may also have another candidate in there, then we have a transitive relationship. Candidate keys gives us transitive relationships from a second normal form perspective, because we have something that could be a key, but it's not a key. We already have a key. If we have multiple keys, we have those candidates in there. You pull those candidates out, you get rid of the transitive relationships. Now you just have single. We just want a primary key. We just want a foreign key. We don't want those extra candidates in there. The extra candidates give us determinants that aren't reliant upon the primary, because they're reliant on this extra key that's in there, but it's not identified as a key. It's a candidate. So candidate is the minimal set of attributes that uniquely identifies each occurrence of the entity type. So a candidate might be social security number, might be visa number, might be student ID, might be something else given to the student. The primary is the one we pick. So if we say student ID or visa ID or social security number, we're saying that that's a candidate. That's a candidate, but it's also primary. It's the one we identify to use as a primary. You don't want to have more than one primary, long story short. You can have that, you're just not in third normal form. You're in second normal form. You're in second normal form when you have more than one primary key in there, or more than one key that can be used as a primary, or more than one determinant. So we have extra candidates in there. So people say just pull the candidates out of there, which is another reason why people get into second normal form instead of third. We have to be in second normal form. If not everybody has a social security number, everyone's gonna have a student ID, but not everyone's gonna have a social security number. And if we're illegal aliens, then we could have visa numbers with fake social security numbers. Who knows? With student IDs. Who knows? What's going to happen with that. So that causes confusion, causes problems. So because of the transitive relationships and transitive dependencies that cause confusion, then we have second normal form. So we have composite keys that are candidate keys that consist of 2 or more attributes. So composite, just like composite attributes or compound attributes or complex attributes, we can turn it and we can create a composite key. Composite key would be an employee ID with dependent ID. Then we would know which employees belong to which dependents for a health insurance policy. Don't let the keys trip you up. A primary key is a uniquely identified key that someone determined to be the determinant for that table. Someone determined to be, that sounds like a recursive definition. So it's a determinant that someone determined. Anyway, long story short, someone picked it out and called it a primary key. It could be a regular old key. It could be any key. It can be the primary key, as long as it's unique. Unique is not necessarily the designated primary key. It's a candidate key. Causes partial relationships, causes partial dependencies, because someone could use it to determine something else, but it's not the primary, which makes it partial. So long story short, you don't want partials in there. Partial anything is not good, because then you can run a count on the table and find out that the count is 50, and then run the count again and you find out it's 55. Oh, what happened to those 5 extra ones? Well, we have some partials in there. Oh. So if you look at it this way, it's this. If you look at it that way, it's that way. Not a good design for the database second normal form. Actually, it could be first normal form depending upon what we did with it and how many partial dependencies we have in there. It could be first normal. So just keep in mind. And then foreign key, which is not on the list, is a primary key used outside of the master table. The master table has the primary. The secondary table that's using the primary, it's foreign. And in Oracle, you can actually, and MySQL as well, you can actually designate it as a foreign. You're designating it as a foreign key, you're making the referential integrity, you're creating it. By just putting it in there and not designating it as a foreign, it's just an extra value in there. There's no requirement that it matches the primary. So foreign keys always have to match the primary. If they don't, we have no referential integrity. So the word referential integrity actually is written on the exam in several spots, in several questions. So because we can have the keys and we can have no referential integrity. If we haven't designated something as a primary and something as a foreign, we don't have it. So referential integrity means that one key references the other. And we've said that it referenced it. We designated it that way. We haven't designated it. There's no referential integrity going on there. Why do we want that? It provides database constraints. Database constraints happen at the table level and the row level. The row level is through the keys, meaning we can only have one student with one student ID in there. That's a row level referential integrity constraint. Excuse me, that's a row level constraint. A table level constraint says that if we have a key here, we have a key over here that matches it. And both of them have to match. Otherwise, we can't have that relationship going on. If we have a student ID over here, we have to have in the registration table a valid student ID to link that up. That's a constraint from a table. It says you can't get into the registration table unless you're a student. You have to register and become a student before you can register for classes. So constraints, just think of them, they actually enforce business rules. Without the constraint, no business rules. We can have people in the registration table that aren't students at the university. We can have people graduating that aren't students at the university. That's not a good constraint to have as a business rule. But you make the business rules into the constraints. You enforce the business rules through the referential integrity at the row level and also at the table level. It makes everything work with in terms of the constraint system. So here's our kind of finished table that has the primary keys as PK, foreign keys as FK, but not in the table. This one here, we have a derived attribute that's going to be the total number of staff that might come into this table here for staff. We have the area that lists the attributes. We have the name of the entities. All entities have names. All relationships should have names. If you don't put a name on a relationship, how's it going to turn into a table? What name? Then you have to arbitrarily come up with it. So there's a lot of schools of thought on that. I'm not going to take off any points if you don't give your relationship names. Actually, you can easily take a bunch of tables, turn them into, some of them get turned into entities, some of them get turned into relationships. You can arbitrarily just give names to some and not give names to others if you wanted to. And the others you're not going to give a name to is they're going to be the relationships. What if you don't want to put a name on it? You don't have to. But eventually you're going to need to put a name on it if you're going to take and translate it into a table, because all tables have names. So then people go, oh, we'll just put a name on it. But if it says manages, it doesn't have to turn into the manages table. Just like students take classes, you could have a takes table, but isn't that really a registration table? So the names can change. You don't really need to use the same name. In fact, when you get this list of tables that have these names that are given to it, the confusion, well, the way that the test taker is going to make the test is to add confusion to it. So you'll be, how can we have an entity called registrations in that particular case? Isn't it takes? So there's no points lost if you change it into takes when really it's a registration table, but you're just making a diagram out of it. So there's no law that says you have to use that. And because when somebody translated that into a table name, Well, the table name may not make any sense for the relationship you're creating, if you think about it. So I'm not going to trip you up with that, but I could have made it more difficult by giving you some really interesting table names and say, how do we make sales invoice into a relationship? Which sales invoice is a relationship. So is cash register receipt. Receipts, those are relationships. They're products of a relationship. It's a table created from a relationship. It's the relationship of the customer going into the store and buying something. So if I were thinking in an entity relationship diagram, I'd say the customer purchases product. Customer frequents bar. We're going back to the bars and the beers and the drinkers. But frequents in that example turned into a table. We had a frequents table because patrons or customers frequent bars. That's 3 tables. Because how do you know what bar? Am I just allowed to go to one bar, or can I go to many bars? If I can go to many bars, I got a table that comes under, it's called frequents. So if that is a better way of understanding it, then you could possibly, and that comes from the SQL lecture actually. But you can build those tables real easily. When you build the tables, you look at that and you go, well, if I have a customers table, I have a frequents table, and I have a bar table. And I was asked to create an entity relationship diagram from that scenario. I have 2 entities and 1 relationship. That's the point I was trying to make earlier. We're not going to have 3 entities. How can frequents be an entity? It's an adjective. It's not a noun. It's an act. It's like someone takes classes, frequents bars, rides the bus. Rides is a table if you can ride more than 1 bus. If you're just riding 1 bus, it's not a table. You're just riding 1 bus. So you're going to put bus in the customer table. If you can only take 1, if there's only 1 bus, then you can only ride 1 bus, then you don't have a relationship table. You have a relationship. You still have the relationship whether you have the table or not. It's still going to be in the diagram. But it's going to be an attribute of one of the other entities that's participating in this relationship. Usually it's an attribute of both, but it doesn't have to be. If a student can only take 1 class, the classes table doesn't need to know who's taking it. The classes table only needs to show that class A, class B, class C, class D, descriptions of the classes, the locations of the classes, the meeting times, the teacher, all that stuff that goes along with the class. And then in the student table, you're only allowed to take 1 class, so you have a field attribute that says class. And you're in C, and you're in B, and you're in A. You only get 1, so you only have to put 1 key in there. One designated class that belongs over here in the class. But what you're sticking in the student table is class ID. And hopefully that class ID matches over here in the other entity called class, where we have the class ID is A, B, and C. So you're linking the relationship through the keys. There's no extra table in that scenario because it's a 1. So whenever you have a 1-to-1, that's the only case that you're not going to have a table. When you have a many, if the many's on this side or if the many's on this side over here, you're going to end up with a table. It's just inevitable. Otherwise, you got to take it down to second normal form. So the concept of the entity relationship diagram is just to reinforce the point, because this example actually just kind of led itself to that direction, is that it creates 3rd normal form tables. How does it create 3rd normal form? Because it enforces the concept of not having the duplicate it takes the redundancy out of it. You don't have any repeating groups. You don't have group 1, group 2. You don't have class 1, class 2, class 3, class 4, class 5. That's a repeating group. You don't have that. That's like 1st normal form or 2nd normal form. That's not 3rd normal form. If you want to enforce and you want to create 3rd normal forms, then if you follow the entity relationship diagrams and you have the manys and that turns into an extra table, you got 3rd normal form out of that. So that's why it lends itself in that direction. Alright, so this is a good review of actually normal forms as well. It's all related. Entity relationship diagrams are giving you 3rd normal forms. It's all related. The reason why you're doing it. In fact, you can take and test the normal forms by putting it into an entity relationship diagram. If you can create a diagram out of it and the diagram makes sense, you're in 3rd normal form. If you can't create a diagram out of it, you get extra relationships and extra entities that don't fit anywhere, then you got a problem with your table set. I'm giving you a decent table set on the exam. I could have made it a lot difficult for you and gave you a second normal form set of tables and had you create a diagram out of that. Then I would have gotten some interesting responses because you can't do it. So I gave you third normal form tables to create an entity relationship diagram from. So otherwise I could have, well, maybe I should be sadistic next time. That might be interesting to see what comes out of that. So the sadistic teacher would have given you a first normal form. And a sadistic teacher would have given you a third normal form database that needed to be in BCNF and told you to normalize it. That would have been sadistic. So you don't have to worry about BCNF to scratch it from your brain. You don't have to on the exam. It just goes up to third normal form. Although I could have given you a what's wrong with this scenario and given you perfect tables that weren't BCNF. That would have been sadistic. Okay, so we have strong and we have weak entities as well. For the purposes of translation, know that strong and weak are the same. Why do you want to put them in a diagram and designate them as strong or weak? Because you have to create, you're supposed to create composites out of those weaks. You have composite attribute as the key. The key is a composite attribute. The primary key, if you don't make a weak entity key, if you don't make that primary key of the weak entity a composite, then you have strong entities. You make it weak because you need to establish the connection, which is the classic mistake about 50% of all databases out there. You definitely see it when you see HR people manually removing dependents. Because if the employee leaves the company, so should the dependents on the health insurance policy. To reinforce that point. If you don't have a composite, you have no relationship between, and they're strong entities. They're just like employees. They're not weak on the health insurance policy, which means you can remove the employee and the dependents are still on there, and you're still paying for it. Which is actually kind of funny because annually most companies will go through, okay, everybody fill out a new form. We're going to start over. Everybody sign up again. And you have to confirm everything, because then they got to go through and manually check, okay, this employee's got A, B, and C. Oh, wait a minute. Okay, wait, what happened to A, B, and C? The employee didn't sign up. Okay, wait a minute now. And then they have to match everything up manually, because what ends up happening is the company is inevitably going to pay for employees that have left. They will be paying for employees, they will be paying for dependents of employees who have left if they don't annually clean all this crap up, which is what they do, because their database isn't enforcing anything. If you want the database to do it, then you'd have what's called a cascading delete. It would cascade through to say that each one of these weak little dependencies can exist if the main strong entity doesn't exist. You get rid of the strong entity, then you cascade the delete out to the weak entities. Now they're gone too. Wow, we lost one employee and 11 people left the health insurance policy. Wow, because they had 10 dependents on there or something. So hopefully you don't have 10 dependents. So and you're going to have that turn into a dependents table because you don't know how many dependents. Maybe you have 0. Maybe you have 10. Maybe you have 2. Who knows how many dependents you have? Well, that's going to be a multi-valued attribute. One employee might have many dependents. So you might have a relationship table that actually comes up showing you which employee belongs to which dependent, if that were the case. But anyway, long story short, that's another way to make a relationship table out of a relationship. So, what do we have here? Advertises them. Oh, this is a attribute that belongs to the relationship in here as well. So, structural constraints for multiplicity. Remembering we have participation and multiplicity. Participation says that an employee has optional participation with the dependence situation. An employee is not required to have a dependent to be on the health insurance policy. That would be a stupid rule. So if you can have a 0 on the participation, you can be on the health insurance policy and not have dependents on that policy, then you're optional participation. If you have full mandatory participation, then an employee wouldn't be able to be on the health insurance policy unless they had at least one dependent on the health insurance policy. So that's going to be optional. So in the old days, people used to show optional versus full mandatory. So it was optional or mandatory were the two switches. It was a 0 or a 1. And you can go 0 dot dot asterisk, meaning it was optional participation, and the 0 on one end was optional or mandatory. And then people went, oh, let's just go 1. So technically, if you have a one-to-many, each student is required to take a class in order to be a student. But technically that's wrong. You can be a student and be on semester break and not be taking any classes. That would be optional instead of mandatory participation. But in the diagram, most people would just go asterisk and leave off the participation. The participation is the first number. The second number is the multiplicity, or the cardinality. So technically the first number is on the one side. So one student takes many classes, or one person, employee, has many dependents. If it's a 1, it's mandatory. If it's a 0, it's optional, which is how that participation works. And on the other side, you go dot dot, or you go colon, and you put the second number in there. The second number is multiplicity. On the exam, I say show multiplicity. I don't care about participation. Put one number there. If you're going to put 2 numbers, you're showing me participation. If you're going to show me participation, then get it right. Is it optional or is it mandatory? I'm not going to take off any points for it, but technically that's what how you should feel. If you're going to write a diagram and you're going to put participation on there, at least make it correct. So I see a lot of people that put 1 colon asterisk. Yeah, we know there's one student, but if you're going to put the 1 there, why not put a 0 there? If you're a student, are you required to take classes if you're a student? I think you're allowed to take a semester off or so. I hear this all the time, actually. I'm on semester break. I'm not going to take classes till spring. Okay, good. They're partial. You're optional. You're not mandatory. So if I were to write the diagram of student taking classes, it would be 0 dot dot asterisk, which means it was optional. But you can forget this concept completely. Just keep in mind for the future, if you write diagrams, people are going to look at you funny if everything's always a 1. That means you don't understand participation. Or you can forget about participation completely and just show multiplicity. If you just put one number on there, you put 1 over here, that means 1 or more. Or excuse me, that means only 1. It doesn't mean 0, it means only 1. If you put an asterisk, that means many. So if I were to put multiplicity or cardinality, multiplicity and cardinality are 2 words that mean the same thing. It means the degree of how many participating entities. Whether we're participating, if we have multiplicity, there's an assumption that we might be. It could be 0 or it could be 1. But the many side is always more than 1. So then people like to put M for multiple or N for any number. Generally, if you're going to write the diagrams out, you're going to put N, meaning that there's a maximum number. It's not infinity. If I have a school bus and I want to say how many seats up to N, means there's a number on that bus. There's 35 seats on the bus, or there's 30 seats on the bus. If I put an asterisk there, or if I put an M there, the M means an asterisk. M means any number. Many. We don't know how many. Meaning we could put 50 people on the bus or 10 people on the bus. But if the bus only has 35 seats, it's really an N. If you want to get nitpicked, if you want to really get nitpicked on that. But yeah, I'm not going to nitpick you on that. You can put an N, you can put an M, you can put an asterisk. I don't care what you put on there. It means more than 1. It means a lot. So what people do in terms of their syntax is now everyone uses an asterisk. So there's an asterisk or there's no asterisk, or there's a 1 or there's a 0. If there's a 0, it means it's optional. If there's a 1, it means there's full participation or mandatory participation. If it's a 1, like a 1 dot dot 1, that means it's a 1-to-1. We can't have many. It's the opposite of an asterisk. So a lot of people will put 1, they'll put an asterisk there, they'll put an M there, they'll put an N there. M and an N and an asterisk is always more than 1. N means we know that there's a number associated with it. M means any number. Because if I'm going to put N's on the diagram, I'm going to use M's for many's and N's, just so I'm consistent. If I'm not going to put N's, or M's. I'm going to use the asterisk, which is what the kind of trend has been, actually. Long story short, I don't care how you put it on your diagrams on the exam. I'll probably just, I find it humorous because I see the mix and match done all the time, and I go, okay, that's great. That's perfect. It's just kind of funny, but I'm not going to take off any points for it. It just means like, oh, okay, all right, that's typical. Multiplicity, the number or the range of possible occurrences of an entity type that may relate to a single occurrence of an associated entity type through a particular relationship. A single occurrence, or more than a single occurrence. You can have a many-to-many. Represents policies or business rules established by the user or the company. We have structural constraints that are also referred to as structural constraints. The most common degree of relationships is the one-to-one. We could have binary relationships with one-to-many, many-to-many, many-to-one, with different relationship associations. Here's the 1:1, where each branch is managed by only one member of the staff, and only one member of the staff can be a branch manager. But over here we can have 0 members of the staff, which means it's optional participation. You can be a member of the staff and not be a branch manager. That's the only thing this is saying. But if you're a branch, you only have one manager. Only one manager at a time. You can get rid of all this stuff and just put a 1 over here. And you can get rid of all this stuff and put a 0 over here if you wanted to. Or leave it alone. Don't put anything on there at all. Because we don't care. Unless you want to enforce the business rules, and then you put a 1 in here. Because only one staff person can be a manager for only one branch. And then we have every property for rent is overseen by 0 or 1 member of the staff. And then we have each member of the staff oversees 0 or more properties for rent. 0 ... asterisk. I'm going to go to the slide that has both of them on there. Well, we have our 3 relationship. It's really the same thing. We just follow it backwards. We say the branch has 1. We could have clients that aren't registering with any staff people at any branches, or we could have a lot of clients that are registering. So you can be a client and not registered, just like you can be a student and not take classes. That would be a 0 ... asterisk. Or you can take any number of classes, or many classes. Here it is. This is the slide I was looking for. Multiplicity is cardinality and participation constraints. So the cardinality is really technically the second number, and the participation is the first number. So in cardinality, one branch is managed by one member of the staff. That's a 1. And one member of the staff manages one branch. That's the 1. But the participation says that all branches are managed. There's mandatory participation for a branch. We have at least 1. Or 0 on this end, meaning that not all staff manages branches. It's optional participation for the branch. And people get confused because this is over here and this is over here, and they go, where do you put the 1? Where do you put the 0? I don't get it. And then you just, if you know what, it's a 0 or it's a 1. It's a mandatory or it's an optional. If you're going to leave it out, it probably makes more sense to most people. Because most people, when they look at this, they go, I don't know what the 0 means. Why didn't we put a 0 over here? Because every branch needs a staff manager. We have to have a staff manager. It's mandatory. So over here, though, we can be a staff member and not manage a branch. But this is really talking about the branch end. The branch, we have all these staff people, and we only want one of them. Some of these people are not going to be branch managers from the staff perspective. So that's where we can get the optional. That's where we get that 0 into there. It's optional participation. Not all the staff manages a branch. But we have people at the branch who are staff, but they're not all managers. Only one of them is. And people look at this and they go, well, how do you know that that 0 is talking about the staff? Well, because of the arrow on the manager's relationship. So people, going back to what I was saying before, the humorous things, they'll put the arrows in the wrong direction and they'll put the participation in, and you'll go, oh. So students have to drop classes. It's required. oh, okay. Or, you know, they'll put stuff in there and you read it and you go, oh. So when in doubt, as they say, leave it out. It's like commas. When in doubt, leave it out. Do you guys are familiar with that? Grammar rules for English. So when in doubt, leave it out. Means if there's a comma and you don't know if you should put a comma in there, leave it out. You probably don't need it. Same thing here. It's probably assumed. When in doubt, leave it out. Just put the multiplicity. On the exam, I just ask you for the multiplicity. I'm not asking you for participation. Which means if I'm only putting multiplicity and I'm only putting one number, if I'm going to put a number in, I'm going to use a 1, or I'm going to use an asterisk, or I'm going to use an M, or an N, or a 0. Those are my only choices. So M is going to mean, well, it's the same as an asterisk. So we also know that we have problems with entity relationship modeling, and that we can have connection traps or traps without connections at all. And just to review a couple of the problems, and to think about these when you put the diagrams together. This is where you could probably take 2 hours with this exam if you overthink it, but don't overthink it. You already got 10 points on the exam if you did the assignment ahead of time. So it's actually better. You'll score better if you don't think. Seriously. Because if you think about it too much, then you get into what's called, what do they call it? Oh God, there's a word for it. There's an expression for it. It's paralysis by analysis. The analysis makes you paralyzed. You paralyzed thinking. It's like when you get stuck in a situation where, you ever see like animals just stop dead in their tracks, and they're like, they're looking at you and they don't know what to do. They get paralysis by analysis. You know, you run into a wild animal, like squirrels do this all the time actually. Just have a squirrel run up to you and they look at you like, and it has a deer in the headlight look, you know, they're just like, because they're paralyzed, because they're thinking, oh my God, there's a human. What do I do? Do I ask for food? No, I'm not going to ask for food. Do I run to the right? No. Do I run to the left? No. I can't look. Don't look to the right. Don't look to the left. They're sitting here, all this crap is going through their heads trying to figure out what they're supposed to do, because they're not supposed to run into a human. It's like the deer that runs out in the middle of the street, and they go, headlights, headlights. Oh my God, I'm not supposed to be here. Humans do this too, actually. There's a train coming. The train's going to hit you. The person will just stand there looking up the train until somebody else moves them out of the way because they're paralyzed. So students do this with exams all the time. You stick an exam in front of them and you ask them what their name is, and they have problems remembering. What's my name? I don't know. What class is this? I don't know. Why am I here? Where am I? You're in the U.S. You're taking a class. You're at ITU. Your name is such and such. Get paralysis by analysis. So if you do that with the entity relationship diagram, you're going to end up sitting there going, oh my God, is it a relationship? Is it an entity? Is it a relationship? Is it an entity? I don't know. Is it multiple? Is it single? So the best thing to do is take your first impression. Look at it. Go, oh, that's this, and just write it down. Because 9 times out of 10, your first impression is the most correct. And then you sit there and you erase it 5 different times, and I always look at the erasure stuff, and I go, oh, look, they had it right. 9 times out of 10, you erase it, you're erasing a good answer, and you're replacing it with a bad answer. So, all right, fan traps, chasm traps, we're going to get done so we can go to lunch here. Just to conclude on some relevant information related to entity relationship diagramming. We have a situation in which we have a relationship. The relationship is given to us, but there's no connection. We're missing a connection. And this is the example I went over when I went over this, probably the first weekend of the weekend class. A staff with divisions and branches, but we don't know which staff is working at which branches because the staff are assigned to divisions and the divisions are assigned to branches. So we can't tell which staff person is working at which branch. And if we look at the scenario, we look at this and we go, well, what branch office does staff number SG37 work at? Well, we don't know because we can't get there. So in this particular way, it's just a matter of restructuring the diagram. So you take the diagram and you change the order that the entities are showing up in, the relationships are appearing in. And then we know that the divisions are operating at branches and the people are working at the branches. So we have the staff working at branches and the branches are working at divisions. So it had to do with the order that you were putting something in. Not to worry, I'm not going to take off any points. If you correctly, for these problems, if you correctly identify the entities and you correctly identify the relationships, that's all I'm asking for. I could have made it more difficult and set you up so that you would come up with a fan trap. And that would be a particular case that would, or I could give you a fan trap or, you know, an ambiguous diagram and have you solve an answer for it. That would be sadistic though. I didn't do that too. This exam is really easy, actually. So restructuring it to get rid of it, we just basically make it so we have a connection between all the staff and all the branches and all the divisions so we know the connections exist. The other choice is when we have ambiguity that goes on where we don't see a connection, where it could go one way or the other. As an example, at which branch office is property PA 14 available? We have branches and we have staff and we have property for rent. We don't know which branch the property for rent is on. So instead we just add another connection so we know. So in this particular case we added this offers relationship. When we add the relationship, then we can tell which branch this property for rent is actually listed at. So we have the branch that has staff that oversees property for rent. We can tell by adding the offers relationship. So in some cases we can add a relationship to avoid ambiguous relationships. We can just put it in there. And then eventually when we translate this into diagrams, we take it out. Because you know you could take out relationships if they're duplicates. So you can have multiple relationships in a diagram that all really are the same thing. Because instead of putting 4 participating entities together by one relationship, you made 4 separate relationships. And you took those 4 separate relationships and you made them all into tables because they were all in the menus. And you go, isn't that the same thing? And then you can look through all the tables and go, oh, that's the same information. If you have 2 more tables that are identical, you get rid of one. You only need 1. So you don't need 2 tables that are storing the same amount of information and the same level of detail, same information. It only has to appear in 1 table. So depending upon how you draw the diagrams, you might end up in a situation in which you've got multiple tables after you've translated it, and if that's the case, then get rid of them. There's no law that says you have to keep the multiple tables. So, all right, well that's kind of the end of it. The lecture itself, I also covered different symbol sets, but as I was mentioning before, you don't need to know any of that stuff. Use whatever symbol set you want. It doesn't really matter. I'm not grading you on your symbol set. You do have to come up with something that you're going to use because you'll end up having to draw a diagram. So kind of come up with you know, it's universally accepted that the rectangle is the entity. And if you're going to draw a relationship, it's a line between the 2 entities. And you can put the name of the relationship on the line. Or you can use the diamond symbol to show the relationship. How you do the cardinality is up to you. Some people like to put the crow's feet on there to show many. Some people like to put an asterisk up there. You don't have to use the asterisk if you're using crow's feet. You're giving me many in the symbol set if you use crow's feet. If you use a single line, some people like to put a 1 through the line or a 0 on the line. If you're going to show cardinality of 0 or 1, or just put a 1. If you just put 1 line on there, it could mean 0 or 1 because you're not showing participation. You're just showing multiplicity. You can do it any way you want, and it doesn't really matter. As long as I can tell the difference between a relationship and an entity. And I've had some people in the past do this, and that's perfectly fine as well. You can put a little symbol set on the bottom. I'm using a P. Oh, okay, what does a P mean? P, a little legend on the bottom. The P is equal to mandatory participation. Okay, well, I didn't ask you to put participation on here. Okay, well, that's fine. I don't care. You can put more on there. You can put more than I asked for on there if you want. I'm not going to ask you for participation. I'm only asking you for multiplicity or cardinality. Questions on entity relationship diagramming. That was a good review, I guess. So hopefully it'll save you some hours of studying. You don't have to do this. Now you can just focus on your SQL skills. You already know all the things with entity relationships. All right, so I'm going to end this video.